When I think of ACT trigonometry questions, I think of the find the side question. It's obligatory. Really, almost every test has one, and they come in a couple different shapes and sizes. The first thing I want you to remember, though, is that the ACT can be solved. The entire math test can be solved without the use of a calculator. So they're never going to say, well, here's a 42-degree angle. Just give me a numeric answer. They're going to do one of two things. They're going to leave it in an expression like we have here, or they are going to give you the big three trig functions for that angle. So they may say sine of 42 is this, tan of 42 is this, and cosine of 42 is this. And still making you pick which one is the right one to use, but that way you can get a numeric answer. People get thrown off by that, though. They tend to think that these problems are harder. So there's a couple things to this. First off, if there's no triangle, please draw a triangle and label it. It will save your bacon more times than you think it will. Second off, once you get that set up and figure out which function you're using, it's really a proportion problem. So let's dig into it. Okay, so Charlie is trying to calculate the height of a building. So let's say this is Charlie's 42-degree angle. And he is 50 feet away. So he's not measuring this way. There's a little bit of common sense sometimes that gets involved in these. He can't measure by line of sight. Charlie's eyes are not a rangefinder, right? So he's measuring the ground distance. He wants to know how tall the building is. Just like a proportion problem, and please check that stuff out if you have trouble on proportions, there's always going to be one length I know and one length I don't know. If there's two lengths I know, it's a Pythagorean theorem problem, right? One length I know, one length I don't. So now that I've got the one length I know and one length I don't, and the angle, I have to pick which function to use. So in a way, the fact that you can't just give a numeric answer is somewhat more restrictive because I'm kind of locked into using this 42-degree angle, right? You know, otherwise I could just say, well, this angle here is 90 minus 42, so 48, and I could use maybe a function I liked better. But I can't here. So I need to figure out which sides I've got in relation to this 42-degree angle. Looks to me like I've got an opposite over here, right? Across the street. And adjacent, it's part of the angle, but it's not the hypotenuse. Part of the angle, not the hypotenuse. So opposite and adjacent, that's tan. So the tan of 42 degrees is what I'm using. So let's think about what tan equals for a second. Tan is a ratio of the length of two sides, opposite over adjacent, right? So the tan of 42 degrees will be equal to, well, we don't know what the opposite is, x over 50. Now it's just a simple matter of getting the x by itself, and we're done. So I'm dividing by 50 here to get rid of that 50 and multiply both sides by 50. And that's it. My answer will be 50 times the tan of 42 degrees. There you go. Is equal to x. By the way, this can throw people off sometimes depending on what their trig instruction has been like. I know this looks weird, but it's just like it's 50x. This is a multiplication thing. 50 is not just sitting out there, just in case you were wondering. All right, that's it for this. It's a relatively simple problem type as long as you get comfortable with the presentation, but definitely work a bunch of them. There's a really good chance you'll see one on test day.